Now, all of this technology gets put into one of its most important and one of its my favorite applications, cars. At CES, Ricky Hudi, the head of electronics of Audi, and a great visionary of the car industry, said that they needed a supercomputer to power future cars. And he wasn't kidding about the metaphoric use of the word. He was using, literally, I need a supercomputer in future cars. Because that car needs to be self-piloted. That car needs to be your smartest robot. That car needs to keep you out of harm's way. That car needs to get you from point A to point B with so much joy and delight that it's almost unimaginable. Ricky Hudi said he needed a supercomputer at their press conference. The next day, Ricky announced that Audi and NVIDIA are partnering together to build and develop the next generation Audi self-piloted car based on the Tegra K1. Let's welcome Andreas Reich to the stage so that he can tell us more about it.
Hi, Jason.
Andreas.
Nice to meet you.
Welcome. It's good to see you.
It's good crazy stuff you see.
Thank you very much. Before we go on, I just want to say something to the friends. Ricky and Matthias wanted to come, but they couldn't make it. I wish you guys were here. I know you guys are busy. See you guys next year. I just wanted to say hi. And so tell us about. You know what? Before we talk about it, why don't we show them one of the many features, one of the many capabilities that is necessary for self-piloted cars. Okay? Imagine a self-piloted car and what it has to do. Remember some of the things I've already talked about. And so let's go ahead and run the video, and Andreas and I will watch it together and we'll talk to it.
Okay, here you can see a view of the car from the side. It's on the camera in the mirror. And there's a car driving beside parking cars. You introduced structure for motion, and we are using this technique to build up a virtual subscription of the environment of the car. And in this subscription, we put fences. You can see it here. And this fences splits the complete space with the free space. The free space is important for us where the car can drive without collisions. And that's very important for piloted driving, of course.
And so let me do this. Let me apply some of the things that I talked about earlier to this particular image. So basically what's happening is there's a camera on the side of the car.
Yeah.
And it's looking sideways here. And what it's doing, of course, is identifying first interesting features. Interesting features it should track. And then it tracks those features. And by the tracking and the multiple images, we're able to project into 3D space, and as a result, we can reconstruct the 3D space. And we can tell that that particular car is closer to us, and as a result, you paint a fence around it. And as we drive, just as we drove past earlier, the space was sufficiently large, and so it's good enough to park a car,
yes,
and you didn't draw a fence. Yes. And that information is extracted using 3D interpretation.
Yeah, and here you need a lot of computing power. We have 4 cameras in the car. It's a 1 megapixel camera through 30 frames. And so we have to calculate 120 million pixels each second. Mm-hmm. And so we are using Tegra K1. It brings supercomputing power into the car. With normal PCs, it's not possible in real time.
And so, of course, a car could drive itself in the future.
Yeah.
I mean, meaning it can really drive itself in the future, right?
Yeah.
I forgot the cue, you guys. Let the car drive itself in the future. For example, maybe some other random cue so that the people in the background, in the back.
Okay, I bring something with me.
You brought this in your suitcase? Ladies and gentlemen, Audi self-piloted car. Now, there's really no reason to back away from it. I think we're not in harm's way. And so let's take a look at this. I mean, what's really amazing is I mean, it's kind of ghostly, actually. There's nobody inside.
Have a look inside.
Is there a short person inside? Is it in the trunk? Maybe it is in the trunk. Let's take a look at the trunk.
Okay.
It's got to be in the trunk.
Trunk.
Everything is in the trunk.
I will open it.
Wow, Andreas, look at that. There's something really beautiful in the trunk.
Yes.
And what is that?
That's the ZFAS. The ZFAS is the central ECU for driver system and for piloted driving. And a very important point in the ZFAS is the Tegra K1. Here you can see a trunk of the past, 1-2 years ago, with a lot of computing powers. Here we have 4 hard computing PCs inside to realize the environment, to calculate the path, and so on. And with this computing power, it was not possible to calculate structure from motion. And that's with the Tegra K1, it's possible now.
So that little tiny Tegra K1 now fits in this computer module, and it fits right here.
Here you can see.
Right here.
Yes, that's the final form factor. And here that's the actual, it's a B-muster.
Well, this is really fantastic. It's really easy to access, and so if we wanted to upgrade our car to a Tegra K7, we could just pull it out and give it a new brain, right?
Yes, like in infotainment. We have the same. We can put out Tegra and put a new one inside.
Well, I've got a lot of friends who would just like to upgrade it themselves.
Yeah.
And so this is going to be fantastic. Andreas, thank you very much. This is, what a great piece of work.
Nice to be here.
Thank you. Beautiful car. Audi's self-piloted car. Well, next time we're going to give it a much, much larger runway, and we're going to have some fun with it. So here it is. The Tegra K1 Z-Fast fits into the trunk, little tiny area in the trunk, and powered the brain of your future self-piloted cars. Really, really exciting. Well, let me summarize very quickly what we talked about. We announced 6 things today. The first thing was we announced Pascal, our next generation GPU architecture enabled by several very important technologies, NVLink and 3D memories, which allows us to get a huge speed up, huge spike up in memory bandwidth and connectivity bandwidth. As a result, we're going to continue to scale the computational capability of these processors for years to come. The second, we announced Titan Z, the most powerful CUDA GPU we have ever built. What's amazing about Titan Z is not only is it powerful, it is whisper quiet and fits naturally and simply into your average PC. One of the hallmarks of Titan, not only is it beastly in performance, but it's elegant in the way it performs. And then there's cloud. We announced machine learning running on CUDA because of the torrent of information and the near infinite amount of computational capability. Machine learning with deep neural nets is going to see an incredible turbocharge in the coming years. Our partnership and announcement with VMware, the largest, most influential enterprise virtualization company in the world. We're partnering together to integrate Grid with ESX, Grid with View, and Grid with View Horizon View DAS. We announced the iRay VCA, the world's first photorealistic, scalable rendering appliance. Because of its clustering capability, because of its distributed computing capability, we're able to take the simple little appliance, connect it to the network, and if you have iRay in your application, it can turbocharge it. iRay is designed into 3ds Max, CATIA, and other packages. And then lastly, the Jetson TK1, the world's first mobile supercomputer, and one of its best applications, computer vision, for applications like self-piloted cars, like robotics. These technologies, these announcements today, are all based on one unified architecture called CUDA. We now have CUDA in PCs. We now have CUDA in the cloud. And finally, we have CUDA in mobile. The leverage that our developers can get as a result of this unified architecture and all of these different platforms is really, really wonderful. You can develop on the PC, deploy in the cloud. You can develop in the cloud, deploy in a car. The same program works literally everywhere. I have one last announcement. And this one is just for fun. One of the greatest games this is the part of the keynote where all of the timing comes unraveled. One of the greatest games of all time is Valve's Portal. This is a game that runs on PC, the Xbox 360, the PlayStation 3. This is a fantastic puzzle game. This is a game that every child should play. It's a three-dimensional teleporting puzzle game. You have a gun that creates a teleporting gun. You create a tunnel. You jump into the tunnel. Whatever physics was happening before then gets carried through the teleporter. So it's really cool. You could be flying sideways into a teleporter, and because that teleporter is connected to the floor of another chamber, you come flying out of it from the bottom up. Unique Valve physics. Really, really cool. Well, we're so excited that Valve has finally ported their application Portal to Shield. And I'm so excited about this application. And I think all of you guys should enjoy it. It is so much fun to play it on Shield that I'm going to give every single GTC registered attendee a free Shield today. They're ready for you outside. You just have to show your badge and get your free Shield. Ladies and gentlemen, thanks a lot for being here. This is the best GTC ever. Have a great time.